Alright, this is a review video to go over all the stuff we learned about rational equations. First thing that I'm going to remind you of is stuff from lesson 8.1. This was a long time ago. This is that inverse versus direct stuff. So compared to direct and neither. So first thing, if we are looking at an equation, inverse y equals a over x, so we look for division. Direct y equals a times x, look for multiplication. Neither, that's going to be something like x plus or some number, we'll call it h. Something along those where it doesn't just look like this simple form here. Next thing would be the table. So with the table, we really look at that a value instead because we don't know what our equation looks like, but we do know what our x and y's are. So for inverse, if I solve for a, it's x times y, so in a table I actually look for multiplication, and if it's a constant, that's when we're here. Now for this one though, our a is equal to a y divided by x, so when I divide them and they're constant, okay, that's when we're here. And then if neither are constant, we're in neither. So neither are constant. Okay. That's pretty much it for that first part of this. But then we also said, hey, if I know that something is relating inversely, it tells me this, then I know I have this equation, and I know I have this equation, a equals x times y. So if I give you some xy pair, you can find an equation for it. So say I told you, hey, we know the points 2, 1, and it relates inversely. Well, my a value then would just be 2. So my equation, y equals 2 over x. But now if it said, hey, but what about if we just knew that x was 10, what would your y be? Well, I just take it and plug it in. What's 2 divided by 10? 1/5. That is all of that for 8.1. 8.2 was all about graphing. So the key with graphing is just to make your table of values in order to help if you need it. Since it's multiple choice though, it's going to be a lot of saying, hey, if you have this graph, which equation does it match to, or if you have this equation, which graph does it match to? So the tables aren't quite as helpful, but you could use it to check values. You could say, hey, I have this equation, I can plug some x, y's in and see if that matches with the graph over here. The main thing that's going to help though, rather than this, is going to be thinking about those transformations. So we have y equals a over x minus h plus k. So in this case, remember, if we have an h value, that's going to move it left and right. A k value is going to move it up and down. So look at your asymptotes. Say, hey, did this shift up, down, left, or right? Because typically they're on our xy axis. But say I have some graph and my asymptotes are actually here. Well, how far did it move? Let's say this is at 1, 2. And this is just 1. Well, it moved to the right 2 and up 1, so my equation will look like y equals, I don't know my a value, but divided by x minus 2, because remember, you have to switch the sign, out here plus 1, because it went up 1 unit. That would be my equation. So look to see, hey, this is my origin. How many over to the right did I go? How many up did I go? That's going to be how you change that equation. That's pretty much it for graphing. If you want more detail on that, watch the full video for graphing. The next one I want to talk about is just, it's not necessarily a specific lesson, but it's simplifying the complex fractions. So say you have like an x minus 5 divided by x squared minus 25, and that's all divided by x squared plus 2x minus 15 over x minus 3. Well, what I can do is I can actually think about this as division. Because remember, this fraction bar is just division. So the key thing is to try and get rid of that bar. So x minus 5 divided by x squared minus 25. Well, that's just being divided by x squared plus 2x minus 15 divided by x minus 3. So once we're here, this is just the division we learned. So first step is to factor everything. So x minus 5 can't be factored, but x squared minus 25, whenever you see something squared minus a value, you need to think a squared minus b squared. So this is an x plus 5 times an x minus 5. Now, I'm also going to do the reciprocal here. So instead of dividing, I'm going to say, hey, that's the same as multiplying by your reciprocal. So x minus 3 is now on the top, and I'm going to factor the x squared plus 2x minus 15. Well, I need something that multiplies to negative 15 but adds to a positive 2. So that's going to be an x minus 5 and an x plus 3. Now that I'm here, I look for like terms. These minus 5s can cancel. But because of the opposite signs here, I can't cancel out my 3's. So our final answer is going to be an x minus 3 divided by, okay, we still had an x plus 5 and an x minus 5. Well, I know that, hey, those actually multiplied to x squared minus 25, so I already know what those simplify to. Boom, final answer. We still have to think about domain though. So we need to say, hey, what values on the bottom here is this not allowed to include? So x cannot be equal to a negative 5, a positive 5 again, so I don't need to write it, it's already there, and a negative 3. So that has to be included in your answers for these. Next up is, what am I thinking? Oh, solving. So let's say we had an equation here. It's just an x minus 2 divided by x is equal to 1/2. When they're like this, there's just the two terms cross multiply. Boom, I would have a 2 times x minus 2 is equal to x. From here you would distribute and you would solve. 2x minus 4 equals x. Bring your x over, add the 4, solve from there. But if I have something a bit more complicated, say we still have that x minus 2 divided by x, but say we had a plus something else before our equals 1/2. Let's say it's a 4 divided by 2x minus 4. So what I want to do here is figure out what is my least common denominator. What would I have as my denominator if I was going to try and add these all together? So my least common denominator, well, this is an x, so I need to have an x in there. I have a 2x minus 4. Well, 2x minus 4 is the same as a 2 times x minus 2. So what I did here was I took this and I factored a 2 out, because if you think about me distributing this, I would be back at a 2x minus 4. So this is going to be my lowest common denominator. What I'll do is I'll multiply both sides by it. 2x times x minus 2 over here. Key thing to remember though is that I'm multiplying this entire side of my equation here. So I have x times 2x minus 4 over here. So I just kept the 2 out on this side, but here I distributed it back in so these could cancel. So when I do this, I'm really saying, hey, this is going to be multiplying to here and to here. So when something cancels, because these x's will cancel, well, when I multiply over here, I'll still have that x. So what that is going to look like is I'm going to have that x minus 2. But now it's no longer over x because they cancel, but it's still going to be times 2x minus 4. Then I'll have a plus 4 times, well, the 2x minus 4's cancel, it's just an x. And that's going to be equal to, over here, these 2's will cancel, leaving an x times an x minus 2. From here, you need to use your box method to multiply these together. Add any like terms. This is going to be quadratic, so you want to get everything to one side and solve. So what that would look like in this case is we would have a 2x squared minus 4x minus another 4x plus 8 plus 4x equals an x squared minus 2x. So actually, some 4x's cancel here, which is nice. I'm going to subtract an x squared over and add that 2x over. So what we're looking at then is an x squared minus 2x plus 8 equals 0. From here, you would have to use quadratic equation because I came up with this off the top of my head. So there's no nice factors here. Typically what you would do next is factor. So you would say, hey, what multiplies to a positive 8 but adds to a negative 2? Nothing really comes to mind. You would need to use quadratic formula, but say this was instead, hey, what multiplies to negative 8 but adds to positive 2? You would say, okay, my factors are an x plus 4 times an x minus 2 equals 0. So then I could find my two factors. We would have here an x equals negative 4 and an x equals 2. Now, this is a lot of work. If you get to a solving question and you're like, I don't have a lot of time left, and you're just like panicking, solving is typically faster, especially if it's a non-calculator portion, but what you can always do, especially on, well, only on multiple choice, rather than free response, you have your 4 options. Well, what if I had one that said negative 4, 2? I can plug those into my original equation to see if they work. I can do that with each one. I'm so supposed to be me. So I'd say, okay, well, what if I had this and that and some other option? I would plug each of them in and eliminate my answers and be like, okay, final answer is going to be A. That is pretty much it for the review video. I'm trying to keep it kind of short for everyone who has lots going on, work, end of the year stuff. I know everything is kind of happening right now for everyone. Good luck tomorrow. I mean, I'll see you and tell you good luck again, but get your homework done. Last chance to correct anything is tomorrow at lunch. That's it. Bye.